Welcome to a peaceful journey through one of the most magnificent objects in our night sky, the Andromeda Galaxy. Let yourself get comfortable, take a deep breath, and allow your mind to drift across the vast cosmic distance to our nearest galactic neighbor. Tonight, we'll explore Andromeda in a gentle, calming way, discovering facts that will help you relax and let go of the day's worries. Close your eyes for a moment and imagine looking up at the night sky on a clear, dark night. Among all those thousands of twinkling stars, there's one fuzzy patch of light that looks different from the rest. It's not a star at all. It's an entire galaxy, the Andromeda Galaxy, and it's the most distant object you can see with your naked eye. When you look at Andromeda, you're seeing light that has traveled for 2.5 million years to reach your eyes. You're looking back in time, seeing Andromeda as it was when our human ancestors were just beginning to walk upright on the plains of Africa. That's how far away it is, and yet it's our closest major galactic neighbor. The Andromeda Galaxy is also known as Messier 31, or simply M31. It was catalogued by the French astronomer Charles Messier in 1764. Though humans have been seeing it for thousands of years, ancient Persian astronomers described it as a small cloud. They didn't know it was a galaxy, of course. The concept of galaxies didn't exist yet. They just knew it was something beautiful and mysterious in the sky, something that had always been there, constant and unchanging through generations. Andromeda is a spiral galaxy, just like our own Milky Way. If you could see it from above, you'd see beautiful spiral arms swirling out from a bright central core, like a cosmic pinwheel slowly turning in space. But from Earth, we see Andromeda at an angle tilted about 77 degrees from edge on. This gives it an elongated oval appearance in photographs, like a glowing disc suspended in the darkness. Even though we can't see it face on, we can still make out some of its spiral structure in detailed images. Those graceful arms traced out by bright blue stars and dark dust lanes. Here's something that might surprise you. The Andromeda Galaxy is huge. It's about 220,000 light-years across, more than twice the diameter of our Milky Way. If you could see the full extent of Andromeda in the night sky, it would appear about 6 times wider than the full moon. But most of Andromeda is too faint for our eyes to see. We only see the bright central core, a small, fuzzy patch. The rest is there, spreading across a vast area of sky, but invisible to us without telescopes and long-exposure photographs. There's so much more to Andromeda than meets the eye, hidden in the darkness, waiting to be discovered. Andromeda contains approximately 1 trillion stars. 1 trillion. That's 1,000 billion, a number so large it's almost impossible to comprehend. Each one of those stars is a sun, possibly with its own planets, its own story. Some of those stars are similar to our sun, quiet and steady, burning for billions of years. Others are massive blue giants, burning bright and hot, living fast and dying young in spectacular supernova explosions. Still others are ancient red giants, stars in their final stages of life, swollen and cool, gently puffing off their outer layers into space. All of these stars, 1 trillion of them, are part of Andromeda, part of one vast cosmic community. Think about this for a moment. With 1 trillion stars, there are probably trillions of planets orbiting those stars. Some of those planets might be rocky worlds like Earth. Some might be gas giants like Jupiter. And some, perhaps many, might be in the habitable zones of their stars, at just the right distance for liquid water to exist on their surfaces. Could there be life on some of those planets? We don't know. We may never know. Andromeda is so far away that we can barely make out individual stars, let alone planets. But the possibility is there. Right now, as you listen to this, there might be someone on a planet in Andromeda, looking up at their night sky, seeing the Milky Way as a faint, fuzzy patch, wondering if they're alone in the universe. Just like we wonder, the Andromeda Galaxy has a mass of about 1.5 trillion times the mass of our Sun. That's an enormous amount of matter, and most of it isn't even in the form of stars. Like all galaxies, Andromeda is surrounded by a halo of dark matter, an invisible form of matter that we can't see, but we know is there because of its gravitational effects. Dark matter makes up about 85% of Andromeda's mass. It's the scaffolding that holds the galaxy together, the invisible foundation that keeps all those stars orbiting around the galactic center. Without dark matter, galaxies like Andromeda couldn't exist. The stars would fly apart, unable to hold together. Dark matter is the silent guardian, the hidden hand that maintains order in the cosmos at the very center of Andromeda. There's a supermassive black hole. Actually, recent observations suggest there might be 2 supermassive black holes orbiting each other at the core, a binary black hole system. Together, they have a mass of about 140 million times the mass of the Sun. These black holes are the gravitational anchors of the galaxy. Everything in Andromeda, all 1 trillion stars, all the gas and dust, all the dark matter, orbits around this central point. The black holes themselves don't do much. They're relatively quiet, not actively feeding on large amounts of matter. They just sit there, massive and patient, holding the galaxy together with their gravity. There's something almost peaceful about that. The idea of these cosmic giants resting at the heart of the galaxy, doing their job simply by existing. Andromeda is moving. Everything in space is always moving, and Andromeda is no exception. It's not just sitting still in space. It's moving through space, and specifically, it's moving toward us. Andromeda and the Milky Way are approaching each other at about 250,000 miles per hour. That sounds fast, and it is, but space is so vast that this speed seems almost leisurely on a cosmic scale. Despite this incredible velocity, Andromeda and the Milky Way won't collide for about 4.5 billion years. That's such a long time that it's hard to even think about. 4.5 billion years ago, Earth was just forming. Life hadn't even begun yet. 4.5 billion years from now, the Sun will be nearing the end of its life. The collision is coming, but there's no rush. The universe takes its time. When Andromeda and the Milky Way do eventually collide, it will be a slow-motion merger lasting billions of years. But here's the comforting part. When we say galaxies collide, we don't mean the stars crash into each other. Stars are so far apart that they'll mostly pass by each other, like two swarms of fireflies, flying through each other on a summer night. The space between stars is so vast that actual stellar collisions will be extremely rare. What will happen is the two galaxies will pass through each other, their gravitational interactions pulling them back together for another pass, and another, until eventually they merge into one larger galaxy. Some scientists have already nicknamed this future galaxy Milky Way. By the time this happens, any life that exists will see an incredible light show in the sky, with new star formation triggered by the collision. Brilliant blue stars being born in vast numbers, and a night sky filled with stars from both galaxies. It will be beautiful. For now, though, Andromeda and the Milky Way are separate, each doing their own thing, slowly approaching each other across the void. There is a kind of cosmic romance in that. Two galaxies drawn together by gravity, destined to eventually become one. They've been approaching each other for billions of years, and they'll continue approaching for billions more. It's the longest, slowest dance in the universe. Let's talk about Andromeda's structure in more detail. Like the Milky Way, Andromeda is a barred spiral galaxy, though its bar structure is more subtle than ours. The spiral arms wind outward from the central bulge, traced by bright young blue stars, glowing pink nebulae where new stars are being born, and dark lanes of dust that block the light from stars behind them. These spiral arms aren't solid structures. They're density waves, regions where stars and gas are temporarily bunched together as they orbit the galactic center. Stars move into the spiral arms, spend some time there, making the arms visible, and then move out again. The spiral pattern persists even though the individual stars are constantly changing position. It's like a traffic jam on a highway. The jam stays in roughly the same place even though the cars in it are constantly moving through and being replaced by new cars. The spiral arms of Andromeda have been there for billions of years, maintained by the gravitational dance of all those trillion stars. Asterisk. Andromeda has a large and bright central bulge, the densely packed core of the galaxy, where stars are much closer together than they are in the spiral arms. In this central region, the stars are mostly old and red, ancient stars that formed when the galaxy was young. They orbit the galactic center in random directions, not in the orderly circular orbits of the stars in the spiral arms. This bulge is so bright that it outshines everything else in the galaxy. When you see Andromeda with your naked eye, you're mostly seeing the light from this central bulge. The spiral arms are there, but they're much fainter, only visible in long exposure photographs. Here's a peaceful thought. Right now, stars are being born in Andromeda, in giant molecular clouds scattered throughout the galaxy. Gas is collapsing under its own gravity, forming dense knots that heat up as they contract. When the temperature and pressure at the center of these knots get high enough, nuclear fusion ignites and a new star is born. This process is happening right now in Andromeda, as it has been for billions of years, as it will continue for billions more. The galaxy is constantly renewing itself, creating new stars to replace the old ones that die. It's a cycle of birth and death, creation and destruction that never ends. There's something deeply comforting about that continuity, that ongoing process of creation. Andromeda also has hundreds of globular clusters orbiting around it. Globular clusters are dense, spherical collections of old stars, typically containing hundreds of thousands or even millions of stars packed into a region just tens of light years across. These clusters orbit in the halo of the galaxy, far above and below the main disk. They're some of the oldest objects in the galaxy, formed when Andromeda itself was young. Looking at a globular cluster is like looking at a fossil, a remnant from the early universe, preserved and unchanged for billions of years. Some of Andromeda's globular clusters contain some of the oldest stars we know, stars that formed when the universe was less than 1 billion years old. They've been here almost since the beginning, silent witnesses to the entire history of the galaxy. The stars in these globular clusters are so tightly packed that if you lived on a planet in the center of a globular cluster, your night sky would be filled with thousands of bright stars, many of them closer than the nearest star is to us. There would be no darkness at night, just a soft glow from all those nearby suns. It would be a completely different experience of the night sky than what we have here on Earth. But it would be beautiful in its own way. A sky filled with neighbors. A community of stars so close you could almost reach out and touch them. Andromeda also has satellite galaxies, smaller galaxies that orbit around it, held by its gravity. The two largest are called M32 and M110, and both are visible in telescopes near Andromeda. M32 is a compact elliptical galaxy, a dense ball of old stars. M110 is a dwarf elliptical galaxy, much smaller and fainter. These satellite galaxies are like moons orbiting a planet, except their entire galaxies orbiting a larger galaxy. They've been companions to Andromeda for billions of years, caught in its gravitational embrace, orbiting endlessly. Eventually, they might be pulled into Andromeda and absorbed, adding their stars to Andromeda's collection. Or they might continue orbiting for trillions of years. Either way, they're not going anywhere. They're part of Andromeda's family. In fact, Andromeda has absorbed other galaxies in the past. Astronomers can see evidence of this in the streams of stars that surround Andromeda. Remnants of smaller galaxies that were torn apart by Andromeda's gravity and incorporated into its structure. These stellar streams are like cosmic fossils, telling us the story of Andromeda's past, of the galaxies it has consumed. Galaxies grow by eating other galaxies. It sounds violent, but it's a slow, gentle process. The smaller galaxy is gradually stretched and pulled apart over millions of years, its stars eventually joining the larger galaxy. It's not destruction, it's transformation. Nothing is lost. The stars continue shining. They just have a new home now. Here's something fascinating. When you look at Andromeda, you're not just seeing it as a static object. You're seeing a dynamic, living galaxy, constantly changing, constantly evolving. Stars are being born and dying. Gas is flowing in and out of the spiral arms. The galaxy is rotating, though so slowly that you'd have to watch for millions of years to see any change. But it's there, all that motion, all that activity. Andromeda is alive in a cosmic sense. It's not a conscious being, but it's a system, a complex interplay of gravity and matter and energy that has been running for over 10 billion years and will continue for billions more. The rotation of Andromeda is complex. Different parts of the galaxy rotate at different speeds. The stars in the central bulge orbit quickly, whipping around the galactic center in just a few million years. The stars in the outer regions move more slowly, taking hundreds of millions of years to complete one orbit. And here's something strange. The outer parts of the galaxy rotate faster than they should, based on the visible matter we can see. This is one of the key pieces of evidence for dark matter. The stars in the outer galaxy are moving so fast that they should fly off into space, but they don't. Something invisible is holding them in place with its gravity, and that something is dark matter. We can't see it, but we can see its effects. It's the glue that holds galaxies together. Let's continue our peaceful journey through the Andromeda Galaxy, drifting deeper into its cosmic wonders. Take another slow, calming breath and let yourself relax even more as we explore this magnificent island of stars. The Andromeda Galaxy is old, very old. Astronomers estimate it formed about 10 billion years ago, not long after the universe itself began. In its earliest days, Andromeda was very different from what it is today. It was smaller, more chaotic, filled with hot young stars, burning bright and blue. Over billions of years, it grew, absorbing smaller galaxies, accumulating more gas and dust, forming new generations of stars. The spiral structure we see today developed gradually, shaped by gravity and rotation. Andromeda has had 10 billion years to become what it is now. 10 billion years of slow, patient growth. When you look at Andromeda, you're looking at something ancient, something that has existed for most of the history of the universe. There's wisdom in age, and Andromeda has been here, quietly shining, for an unimaginably long time. Think about the light from Andromeda. The photons, the particles of light that enter your eye when you look at Andromeda, began their journey 2.5 million years ago. Back then, Earth was in the middle of an ice age. Saber-toothed cats and woolly mammoths roamed the planet. Our earliest human ancestors were just beginning to make simple stone tools. Those photons have been traveling through space all this time, crossing the vast emptiness between galaxies, and they finally reach Earth right when you happen to look up. You intercept them with your eye, and in that moment, you connect across space and time to something that happened millions of years ago. That's incredible. That's profound. Every time you see Andromeda, you're touching the ancient past. Andromeda contains vast amounts of dust. This dust isn't like the dust you find in your house. It's made of tiny particles, smaller than smoke particles, consisting of elements like carbon, silicon, and iron. This dust is created in the atmospheres of old stars and is blown into space when stars die. It accumulates in the space between stars, forming dark clouds that block visible light but glow in infrared. These dust clouds are where new stars are born. The dust blocks light, creating the dark lanes you can see in photographs of Andromeda, threading through the spiral arms like cosmic highways. But within those dark lanes, hidden from view, new stars are forming, collapsing out of the dust and gas, lighting up to continue the cycle. Darkness and light are always connected. One leads to the other. In the spiral arms of Andromeda, you'll find emission nebulae, clouds of gas that glow with a characteristic pink or red color. These nebulae are lit up by the radiation from hot young stars that have recently formed within them. The ultraviolet light from these stars ionizes the hydrogen gas in the nebula, causing it to emit light. These glowing nebulae are stellar nurseries, places where star formation is actively happening right now. If we could visit Andromeda and fly through one of these nebulae, we'd see baby stars still surrounded by the gas and dust they formed from. And we'd see protostars, objects that are still collapsing and haven't yet ignited fusion. These are star systems in their infancy, and given enough time, some of those protostars will develop planets, and some of those planets might develop life. The future is being born in Andromeda's nebulae. Andromeda also has supernova remnants, the expanding shells of gas left behind when massive stars explode. These remnants are visible as wispy, delicate structures, often ring-shaped or bubble-shaped, expanding outward at thousands of miles per second. Inside these remnants, the gas is incredibly hot, millions of degrees, and it glows in X-rays. Over tens of thousands of years, the remnant will expand and fade, eventually merging with the surrounding interstellar medium, enriching it with heavy elements forged in the supernova explosion. Elements like oxygen, iron, carbon, and nitrogen. The building blocks of planets and life are scattered into space by supernova. Every supernova is an act of cosmic generosity, a star giving back to the universe everything it created during its life. The iron in your blood, the calcium in your bones, they were created in stars and scattered by supernova, perhaps in Andromeda, perhaps in the Milky Way. We're all made of star stuff. Let's think about the sheer scale of Andromeda for a moment. It's 220,000 light years across. If you could somehow travel at the speed of light, the fastest speed possible in the universe, it would take you 220,000 years to cross from one side of Andromeda to the other. And remember, nothing with mass can actually travel at the speed of light. Any realistic spacecraft would take much, much longer. If we could build a spacecraft that traveled at 1% of the speed of light, which would be an incredible achievement, it would still take 22 million years to cross Andromeda. The galaxy is so vast that even at speeds we can barely imagine, it would take longer than human civilization has existed just to travel across it. Space is big. Really, really big. And that's okay. There's no need to rush. The universe has all the time in the world. Andromeda's spiral arms are home to open star clusters, loose groupings of young stars that formed together from the same cloud of gas and dust. Unlike globular clusters, which are ancient and tightly packed, open clusters are young and spread out. They contain anywhere from a few dozen to a few thousand stars, and they gradually disperse over hundreds of millions of years as the stars drift apart. But for a time, these stars are siblings, born together, traveling through the galaxy together. There's something beautiful about that, a family of stars, close for a while before eventually going their separate ways. It reminds us that everything changes, relationships shift, but the time we have together is meaningful. The stars in Andromeda come in every color imaginable. The hottest stars shine blue-white with surface temperatures of 20,000 degrees or more. Medium temperature stars, like our sun, glow yellow or white. Cooler stars shine orange or red with surface temperatures of just a few thousand degrees. And the very coolest stars, called red dwarfs, barely glow at all, emitting most of their light in the infrared. If you could see Andromeda in all wavelengths of light, not just visible light, it would be a dazzling rainbow of colors, each star contributing its own hue to the cosmic palette. The galaxy is a work of art painted with stars. Andromeda is part of what astronomers call the local group, a collection of more than 50 galaxies bound together by gravity. The local group includes the Milky Way, Andromeda, and many smaller galaxies, including the Triangulum Galaxy, the Large and Small Magellanic Clouds, and dozens of dwarf galaxies. Together, these galaxies form a loose cluster about 10 million light-years across. The local group is our cosmic neighborhood, our corner of the universe. Within the local group, galaxies interact, their gravity affecting each other, sometimes pulling each other, sometimes exchanging stars and gas. It's a family of galaxies, all connected, all influencing each other. We're not isolated. We're part of a community. Within the local group, Andromeda is the dominant member, the largest and most massive galaxy. It's the elder sibling, you might say, the one with the most influence. The Milky Way is a close second, but Andromeda wins in terms of size and stellar population. However, recent measurements suggest the Milky Way might be more massive than we thought. With more dark matter, so the competition is closer than we realized. But it doesn't really matter who's bigger. Both galaxies are magnificent. Both are home to hundreds of billions of stars. Both are worthy of admiration and wonder. Let's talk about viewing Andromeda from Earth. If you want to see it with your own eyes, you need to find a dark location away from city lights. Light pollution washes out the faint glow of Andromeda, making it impossible to see. But in a truly dark sky, Andromeda is easy to spot. It's located in the constellation Andromeda, which is visible in the northern hemisphere from summer through winter and best seen in autumn. The galaxy appears as a faint, fuzzy, oval patch, about as wide as the moon, but much dimmer. It doesn't look like much to the naked eye, just a smudge of light. But when you know what you're looking at, when you know that smudge contains 1 trillion stars and is 2.5 million light years away, it becomes awe-inspiring. You're seeing another galaxy with your own eyes. You're looking across intergalactic space. That's remarkable. Through binoculars or a small telescope, Andromeda becomes more impressive. You can start to see its oval shape more clearly, and you can make out the bright central core and the fainter outer regions. You might even glimpse the 2 satellite galaxies, M32 and M110, as tiny smudges near the main galaxy. With larger telescopes and long exposure photography, the full beauty of Andromeda is revealed. You can see the spiral arms, the dust lanes, the star-forming regions, the structure and detail that makes Andromeda not just a smudge, but a complex, dynamic system. Every photograph of Andromeda shows something new, some detail or feature that wasn't visible before. It's endlessly fascinating. Astronomers study Andromeda intensely because it's close enough to observe in detail, but far enough away to see as a whole. We can't see the Milky Way from outside because we're inside it. But we can see Andromeda from outside, giving us a view of what a large spiral galaxy looks like. Many of the things we've learned about galaxy structure and evolution come from studying Andromeda. It's our reference point, our template for understanding galaxies in general. In a sense, studying Andromeda helps us understand our own galaxy better. We look at Andromeda and see ourselves, or at least what we might look like from the outside. Here's an interesting fact. Andromeda has a double nucleus, 2 bright concentrations of stars at its very center. For a long time, astronomers thought one of these was the true center and the other was a coincidental alignment of stars. But it turns out both concentrations are part of the same structure, a disk of old blue stars orbiting the supermassive black holes at the core. This disk is inclined, and we see it edge on, creating the illusion of 2 separate nuclei. The true center of Andromeda is actually between these 2 bright spots, marked by the location of the supermassive black holes. It's a reminder that things aren't always what they seem. Sometimes you need to look deeper to understand what's really going on. The environment around Andromeda is not empty. The space between Andromeda and the Milky Way contains diffuse gas, mostly hydrogen, at very low density. This is the intergalactic medium, the gas that fills the space between galaxies. It's incredibly thin, with only about 1 atom per cubic meter. But it's there, connecting galaxies across the void. In some sense, Andromeda and the Milky Way are already touching. Their outer halos of gas extending far beyond the visible galaxies and overlapping. The boundary between galaxies is fuzzy, not sharp. Galaxies blend into their surroundings. Connected to the larger cosmic web, Andromeda is part of that cosmic web, the large-scale structure of the universe. On the very largest scales, galaxies aren't distributed randomly. They're arranged in filaments and walls, long chains and sheets of galaxies separated by vast voids where few galaxies exist. The cosmic web looks like a three-dimensional spider web or foam, with galaxies concentrated along the strands and in the intersections. Andromeda and the Milky Way are part of a filament, a strand of this cosmic web. We're not in the middle of nowhere. We're on a highway of sorts, a stream of matter flowing through the universe. Everything is connected, part of a larger pattern. Let's think about the future of Andromeda, beyond its eventual collision with the Milky Way. After the two galaxies merge into Milkomada, what then? The merged galaxy will be an elliptical galaxy, a smooth, featureless ball of stars without the spiral structure of either parent galaxy. Star formation will eventually slow down as the gas is used up or blown away by supernova and stellar winds. The galaxy will age, its stars gradually dying, until eventually it's filled mostly with long-lived red dwarf stars and the remnants of dead stars. White dwarfs, neutron stars, and black holes. This won't happen for trillions of years. But eventually, Milkomada will become a quiet, dark place, a galaxy of embers slowly cooling. But that's okay. Everything has its time. Galaxies, like stars, like planets, like us, are not eternal. They have beginnings and endings, and the journey between those points is what matters. But we're getting ahead of ourselves. Right now, Andromeda is vibrant and active, full of young stars and ongoing star formation. It's in the prime of its life, if galaxies can be said to have a prime, and it will remain this way for billions of years to come. There's no rush. The universe is patient. Andromeda will continue turning, its stars will continue shining, and somewhere in that vast collection of suns, there might be beings looking back at us, seeing the Milky Way as we see Andromeda, wondering what's out there, wondering if they're alone. Perhaps one day we'll find a way to communicate across that vast distance, to send a message to Andromeda and wait millions of years for a reply. Or perhaps we'll never know if anyone is there. Either way, the wondering is beautiful. Here's a peaceful thought to carry with you. Andromeda has been shining for 10 billion years, long before Earth existed, long before the sun was born. It was there when the universe was young, and it will be there long after we're gone. It's a constant presence in the universe, a lighthouse in the cosmic ocean, a reminder that some things endure. When you look at Andromeda, you're seeing something that has witnessed almost the entire history of the universe. It's seen galaxies form and collide. It's seen stars born and die. It's been through so much, and yet it's still here, still beautiful, still turning. There's comfort in that persistence, that ability to endure. If Andromeda can last 10 billion years, you can make it through today. Your struggles are real, but they're also temporary. The universe has been here a long time, and it will be here long after your worries have faded. You can take strength from that. Andromeda doesn't judge. It doesn't care about your mistakes or your failures. It just exists, peacefully spinning in space, minding its own business. It's been doing this for eons, and it will continue doing it for eons more. There's something liberating about that indifference. The universe isn't watching you, waiting for you to fail. It's just here, vast and beautiful, and utterly unconcerned with human drama. You can let go of the pressure. You can just be. You're a part of this universe, made of the same atoms as Andromeda stars, subject to the same physical laws, connected to everything else in this vast cosmic web. You belong here. You're exactly where you're supposed to be as you drift closer to sleep. Imagine floating in space between the Milky Way and Andromeda. You're suspended in the void, surrounded by darkness, but you're not cold or afraid. You're at peace. To one side, you see the Milky Way, our home galaxy, a great spiral of light with the sun as just one tiny star among billions. To the other side, you see Andromeda, larger and brighter, its spiral arms stretching across your field of view. Both galaxies are slowly approaching each other, moving through space in their eternal dance. You're a witness to something cosmic, something that transcends individual lives and concerns. You're seeing the universe as it really is, vast and ancient and beautiful beyond words. Let's continue our peaceful exploration of the Andromeda Galaxy, diving deeper into its wonders and mysteries. Allow yourself to relax even more, breathing slowly and steadily. As we journey further into this magnificent cosmic neighbor, one of the most fascinating aspects of Andromeda is its halo. Every large galaxy is surrounded by an enormous halo of hot gas, dark matter, and scattered stars, and Andromeda's halo extends much farther than the visible galaxy itself. Recent observations have shown that Andromeda's halo of gas extends up to 1 million light-years from the galactic center. nearly half the distance between Andromeda and the Milky Way. This means that, in a sense, the halos of our two galaxies are already touching, already overlapping. We're already in each other's space, connected by these tenuous clouds of hot gas. The collision between our galaxies has, in some ways, already begun. It's just happening so slowly, so gently, that we can barely detect it. Everything in the universe happens at its own pace, and galactic interactions are the slowest dances of all. This halo gas is incredibly hot, heated to millions of degrees by supernova and stellar winds from dying stars. At these temperatures, the gas glows in X-rays, invisible to our eyes, but detectable by space-based X-ray telescopes. The halo is a reservoir of material, gas that could eventually fall back into the galaxy and form new stars. It's also a record of the galaxy's history, containing elements forged in previous generations of stars and expelled into space. When you study Andromeda's halo, you're reading the galaxy's biography, written in atoms. Let's think about the stars in Andromeda's halo. Unlike the stars in the disk, which orbit in orderly circular paths, the halo stars have random, elliptical orbits that take them far above and below the galactic plane. These halo stars are among the oldest in the galaxy, formed in the earliest days of Andromeda's existence. They're ancient witnesses, having orbited the galaxy billions of times, seeing the galaxy evolve and change around them. Some of these halo stars might be as old as the universe itself, formed when the first generation of galaxies came together. They've been around for almost the entire cosmic story. Andromeda contains approximately 450 globular clusters, far more than the Milky Way's 150 or so. These globular clusters are scattered throughout Andromeda's halo, orbiting the galaxy in various directions. Each globular cluster is a small city of stars, typically containing hundreds of thousands of stars packed into a sphere just tens of light years across. The stars in globular clusters are very old, dating back to when Andromeda was young. They're metal poor, meaning they contain very few elements heavier than hydrogen and helium. Because they formed before many generations of stars had produced and distributed heavier elements. Globular clusters are time capsules, preserving conditions from the early universe. When we study them, we're learning about what the universe was like billions of years ago. Some of Andromeda's globular clusters are truly massive. One particular cluster, called G1 or Mayall-2, is the brightest globular cluster in the local group. It's so bright and massive that it was once thought to be a small galaxy in its own right. G1 contains several million stars and has a mass of about 10 million times the Sun. It orbits Andromeda at a distance of about 130,000 light-years from the galactic center, taking hundreds of millions of years to complete one orbit. From Earth, we can just barely see G1 as a faint point of light near Andromeda. It's remarkable that we can detect something so distant, a single cluster of stars in another galaxy, testament to the power of modern telescopes and the clarity of the night sky. Now, let's talk about something truly mysterious. Andromeda appears to have an extended disk of stars rotating in the opposite direction from the main disk. This is highly unusual. Most of a galaxy's stars orbit in the same direction, all going around the galactic center like cars on a racetrack. But in Andromeda, there's a population of stars going the wrong way, orbiting clockwise, while most stars orbit counterclockwise. This counter-rotating disk is probably the result of a past merger with another galaxy. When galaxies collide and merge, their stars can end up with all sorts of different orbits. The counter-rotating stars in Andromeda are immigrants, visitors from another galaxy that became part of Andromeda billions of years ago. They still remember their old home in their orbits, moving differently from the native stars. It's a reminder that galaxies have complex histories, shaped by interactions and mergers over billions of years. Let's slow down and think about the distances within Andromeda. The galaxy is so large that even light takes time to cross it. A light beam starting from one edge of Andromeda would take 220,000 years to reach the other edge. During that time, on Earth, all of human history would unfold multiple times over. Civilizations would rise and fall. Species would evolve and go extinct. Continents would drift. The galaxy is so vast that even at the fastest speed in the universe, crossing it is an epic journey. And yet, to someone looking at Andromeda from a distant galaxy, it would appear as just a small, faint smudge, insignificant in the vastness of space. Everything is relative. What seems enormous up close appears tiny from far away. Your problems, your worries, they feel huge to you, and they are real and valid. But zoom out far enough, and they become invisible, lost in the immensity of space and time. This perspective doesn't diminish your experiences, but it can help you carry them more lightly. Here's a beautiful thought. Right now, in Andromeda, there are stars dying. Old red giants are puffing off their outer layers, creating planetary nebulae, glowing shells of gas surrounding the dying star's core. Massive stars are exploding as supernova, briefly outshining entire galaxies, scattering their enriched material into space. White dwarfs are slowly cooling, fading from white to yellow to red to black over trillions of years. Neutron stars are spinning, some of them pulsing with incredible regularity, beaming radiation into space like cosmic lighthouses. Black holes are lurking in the darkness, invisible but present, warping space around them. All of these processes, the entire life cycle of stars, is playing out in Andromeda right now, just as it is in the Milky Way, just as it is in every galaxy in the universe. The cosmos is alive with activity, with transformation, with the endless cycle of creation and destruction that drives the universe forward. And right now, in Andromeda, there are stars being born. In cold, dark molecular clouds, gravity is pulling gas and dust together, forming dense cores that will become protostars. These protostars are heating up as they contract, slowly approaching the temperature and pressure needed for nuclear fusion. Some have already ignited, beginning their long careers as hydrogen-burning stars. Around some of these young stars, disks of gas and dust are forming, and within those disks, planets are beginning to coalesce. Dust grains are sticking together, forming pebbles, then boulders, then planetesimals, then protoplanets. Given time, some of these planets will become worlds, some rocky like Earth, some gaseous like Jupiter, some icy like Neptune. And maybe, just maybe, on some of those worlds, the conditions will be right for life to begin. It might already be happening. Life might be emerging in Andromeda right now, taking its first tentative steps, just as it did on Earth billions of years ago. Imagine what it would be like to live on a planet in Andromeda. Your sun might be a star much like ours, or it might be very different. A red dwarf that barely glows, or a hot blue-white star that burns with intense radiation. Your sky might have one sun, or two, or even three if your planet orbits in a multiple star system. At night, you'd look up and see a sky full of stars, just as we do. But those would be Andromeda stars. A different arrangement of constellations, different patterns in the sky. And if you looked carefully, if your planet happened to be positioned just right, you might see a faint, fuzzy patch in your sky. The Milky Way, our galaxy, seen from Andromeda. You'd be looking at our home from 2.5 million light years away, seeing it as it was in the distant past, just as we see Andromeda from our perspective. Two civilizations, if they both existed, both looking across the void at each other's galaxies, both wondering if they're alone. The idea of life in Andromeda is purely speculative, of course. We have no evidence of life beyond Earth yet, but the ingredients are there. Andromeda has all the same elements we have, forged in stars and scattered by supernova. It has planets, billions of them probably, orbiting its trillion stars. Some of those planets are probably in habitable zones, at the right distance from their stars for liquid water to exist. Water, carbon, nitrogen, oxygen, all the building blocks of life as we know it, they're abundant in Andromeda. The chemistry is there. The energy is there. The time has been there. 10 billion years for life to arise and evolve. If life can happen once on Earth, maybe it can happen again, maybe many times. Maybe it's common throughout the universe. Or maybe Earth is special, a rare oasis in a mostly barren cosmos. We don't know yet, but the question is fascinating. And Andromeda is one of the places where answers might exist. Let's think about the light pollution in Andromeda. Not the kind from cities, but from the stars themselves. In the central bulge of Andromeda, stars are packed much more densely than they are near our sun. If a planet orbited a star in Andromeda's core, the night sky would be filled with thousands of bright stars, many of them closer than Proxima Centauri is to us. The combined light from all those stars would mean there's no true darkness, just a soft, perpetual twilight. It would be a completely different experience of night, a sky that never goes dark, always glowing with starlight. Some might find that beautiful, a sky full of neighbors, a reminder that you're never alone. Others might miss the darkness, the solitude of a truly dark night. Either way, it would be different from what we experience here in the quieter suburbs of the Milky Way. Andromeda's gravitational influence extends far beyond its visible boundaries. The gravity of the galaxy affects its satellite galaxies, pulling on them, causing tidal forces that stretch and distort them. Over time, some of these satellite galaxies will be torn apart, their stars scattered into streams that orbit Andromeda like rivers of light. We can already see evidence of this happening. There are stellar streams around Andromeda, long thin ribbons of stars that mark the paths of satellite galaxies that have been disrupted. These streams are fragile structures, easily disturbed by gravitational interactions, but they persist for millions of years, slowly dispersing and fading. They're beautiful in their delicacy, like spider webs glistening with dew, intricate and temporary. One of the challenges of studying Andromeda is that we're seeing it from only one angle. We can't fly around it to see it from different perspectives. We're stuck with the view we have from Earth, tilted at about 77 degrees. This makes it harder to understand the three-dimensional structure of the galaxy. Astronomers have to use clever techniques, measuring the velocities of stars and gas to infer how the galaxy is oriented and how its material is moving. It's like trying to understand a sculpture by looking at a single photograph of it. You can learn a lot, but there's always some ambiguity, always some uncertainty. The universe keeps its secrets revealing them slowly, making us work for our understanding. But that's part of the joy of astronomy. We're detectives, piecing together clues, building models, testing hypotheses. Every observation tells us something new. Every measurement refines our understanding. Andromeda has been studied for decades, centuries even, and we're still learning new things about it. Recently, astronomers discovered that Andromeda's disk is warped, not perfectly flat, but bent like a potato chip. This warping is probably caused by gravitational interactions with satellite galaxies. It's a subtle effect, but it tells us something about the forces shaping the galaxy. Science is a process, not a destination. We're always learning, always discovering, always refining our picture of reality. Here's something calming to think about. Andromeda doesn't know we're watching it. It has no awareness of the countless hours astronomers have spent studying it. The thousands of images that have been taken, the papers that have been written. It just exists, doing what galaxies do, turning slowly, forming stars, evolving over cosmic time. It's completely indifferent to our curiosity, our wonder, our attempts to understand it. And that's okay. The universe doesn't need us to understand it. It was here long before we existed, and it will be here long after we're gone. We study it because we're curious, because we want to know, because understanding brings us joy and satisfaction. The universe is a gift that doesn't expect gratitude, a mystery that doesn't mind being investigated. We're free to wonder, to question, to seek answers, with no pressure, no judgment, no deadline. Andromeda's motion through space is influenced by the gravity of all the other galaxies in the local group. It's not moving in a straight line. Its path is curved, bent by the gravitational pull of the Milky Way, the Triangulum galaxy, and all the smaller galaxies in the neighborhood. It's a complex dance, a gravitational ballet involving dozens of dancers, each one influencing all the others. The Milky Way and Andromeda are the two largest dancers, and they dominate the choreography. But the smaller galaxies play their parts too, adding subtle variations to the overall pattern. Everything is connected. Every piece of matter in the universe exerts a gravitational pull on every other piece. We're all part of one vast, interconnected system in about 4 billion years. Give or take, Andromeda and the Milky Way will begin their first close pass. The two galaxies will interpenetrate, passing through each other like ghosts. Stars from Andromeda will mix with stars from the Milky Way. New waves of star formation will be triggered as gas. Clouds collide and compress. The night sky, as seen from any surviving planet, will be spectacular. filled with brilliant young stars and glowing nebulae. But then the galaxies will separate, pulled apart by their momentum, only to fall back together for another pass. This process will repeat several times over the next few billion years, each pass mixing the galaxies more thoroughly, until finally they settle into a single merged galaxy. The whole process will take about 6 billion years from start to finish. It's the slowest collision imaginable, playing out over timescales that dwarf human history. But it's happening. The future is already written in the gravitational equations. Andromeda and the Milky Way are destined to become one. But that's billions of years away. For now, Andromeda and the Milky Way are separate, distinct, each beautiful in its own right. We can appreciate them individually before they merge. We can study Andromeda as it is now, learn from it, marvel at it. The present moment is precious because it's temporary. Nothing lasts forever. Not stars, not galaxies, not even the universe itself. Everything changes, everything passes, but that doesn't diminish the beauty of what exists right now. If anything, it enhances it. Andromeda is beautiful, partly because it won't always be as it is now. The galaxy you see tonight is different from the galaxy that existed yesterday, and different from the galaxy that will exist tomorrow. You're seeing a unique moment in Andromeda's long history, a moment that will never come again. Every night is a new Andromeda, subtly different from the one before. If you enjoyed this peaceful journey through the Andromeda Galaxy, consider subscribing to our channel for more relaxing stories that help you drift into deep, restful sleep. If this video brought calm to your mind, give it a like and share it with someone who might need a soothing escape tonight. Let us know in the comments which Andromeda fact you found the most relaxing, or what cosmic topic you'd like us to explore next as you rest. Remember that even though Andromeda is over 2 million light-years away, its soft glow still reaches you across the vast universe. Just like that ancient light, your presence also carries meaning far beyond what you see. You are connected to something greater, something beautiful, something infinite. Take this peace with you not only into your dreams tonight, but into your morning tomorrow. Until next time, keep looking up, keep wondering, and let the calm of the cosmos guide you. Sweet dreams, and may the stars of Andromeda watch over your night. Good night.